Well, sir, I think you can start with the welcome address. Yeah.
Supposed to start or you are supposed to start?
No, I'll just start and then, yeah. Good afternoon, everyone, for joining this webinar, and thanks for all your valuable time. Now, I'll request Mayur K. Shah, who is our technical committee advisor. Meteor is all for as far as MTech is concerned. Mayur K. Shah is a great support to us, and I'll request Mayur K. Shah to give his welcome speech. Yeah.
Thank you, Ajit ji. Dear participants and our chairman, GC chairman AIPMA, and MTech leader and founder, whatever you call, Sri Arvind Bhai. On behalf of Arvind Bhai, I welcome you all to this webinar on 3D printing, right, Ajit ji? Okay. We also thank Samir ji and Pratik ji for presenting this webinar. So kindly be attentive, and we'll definitely have some question answer session at the end, right, Ajit ji?
Yes, sir. Yeah.
Okay. You can continue, Ajit ji.
Okay. Thanks, Mayur sir. Thanks, Arvind sir. Arvind sir is our chairman of the MTech, and is like a godfather to all of us for the MTech APMA, and he's always we work under guidance from Arvind sir and Mayur sir. So thank you for attending this webinar. And dear participants. As you know, I'll say some few words about MTech. As you most of us know about APMA, that is All India Plastic Manufacturers Association, and it is 70 years old, and we have more than 25,000 members. Now, APMA has taken this great leap and great initiative to start MTech so that we upskill the youth and they are ready for plastic industry. So this is a great step taken by APMA, and of course with the blessings of Arvind Bhai and Mayur Bhai. So now, in accordance with what the objectives of the MTechs are, now this is a webinar series we have started, and thanks to Samir and Pratik for participating in this, and they will be making I'm very confident that they will be making a very lovely and very knowledgeable presentation, which will help us out. Thanks to all of you. Now, I will Nikita to take over and say a few words about the speakers. Yeah, thanks all of you.
Thank you, sir. I would also like to thank Arvind sir, Mayur sir, Siddharth sir to join today's webinar. Thank you so much. And I will be sharing few slides about AIPMA's MTech, and then we will start the webinar. Okay, I hope the screen is visible.
Yeah, it's visible. Yeah.
Okay. So we are the All India Plastic Manufacturers Association. We are an 78-plus-year-old association, and we branch out into two parts. So one is Plastivision, so where we are the second largest exhibition, we hold the second largest exhibition in plastic industry. And also we are branched out into AIPMA's MTech, where we provide knowledge and services for all the latest technologies that are coming up in plastic industry. So about today's webinar, our speaker, Mr. Samir and Mr. Pratik, will be, handling this webinar today. I have already shared with you the key takeaway points. So I hope you will enjoy today's webinar. And lastly, We are also having our newest course. So it's on plastic and packaging. And this time we will be talking about testing and evaluation of plastic packaging materials. So if you all are interested, any one of you all to know more about this topic, you all can definitely come and contact us. You can also join our curtain raiser for this course, so we can help you out to resolve your queries and help you understand more about plastics. So I'll stop over here and I'll hand over to Mr. Prateek and Samir. So thank you.
Thank you, Nikita. Yeah, I'll take it over from here. So,
Yes.
hello all. I'm Prateek Southmal. I work in the capacity of an application engineer at Sri Rapid Technologies. So, just a short background about myself. I've done my graduation in mechanical engineering and masters in plastics technology, and I've been a sales professional for the past 7-8 years, and recently transitioned my career into a technical role. And I've been working with the SRT for the past 3 years now as an application engineer, helping our customers identify the right 3D printing or additive manufacturing technology for their specific application. Now, Sri Rapid Technology is into providing digital manufacturing solutions, right from reverse engineering to scanning, 3D printing, and post processing. And they have been representing various OEM brands, and one of them being the pioneer of 3D printing itself, that is 3D Systems. 3D Systems is into different 3D printing technologies, and one of them being the Figure 4 technology, which is the topic of the webinar today. So I'll just share my screen here. Let me know if my screen is visible.
Yes, it's visible.
Yeah, so Figure 4 is the topic of webinar today, where we'll cover the Figure 4 printer, the technology itself, its material portfolio, the application, and how it is going to bridge the gap between industry and education. So let's get right into it. So Figure 4 standalone, it's basically an ultra fast and affordable industrial 3D printer. And what exactly is Figure 4? Basically, it's a printer based on DLP technology, digital light processing, the technology which produces, rapidly produces photopolymer parts. Basically, DLP uses a projected light to cure, photopolymer resins, the entire layer, cures entire layer at once. So basically, it's an affordable solution for functional prototyping and low production volumes. It's also ultra high. It also has ultra high printing speed that I'll cover in the subsequent slides, how it's able to achieve that kind of speed. And it is known for giving extremely good parts and, accuracy. So build volume of this printer is basically 125 by 70 and 196 in the height. And it uses a true HD projector of 1920 by 1080 pixels. So the XY resolution of this printer is 65 microns. And you can produce parts with the variable layer thickness ranging from 10 to 100 microns. It comes with the proprietary software of 3D Systems, that is 3D Sprint, which is also 3D Connect capable. Basically, you can monitor your prints remotely. So Figure 4 is basically productivity redefined. You can get functional prototyping iterations done within the same day. If you have low volume production of, say, output volumes of up to 500 parts per month are achievable. And you have 3 printing modes, draft, standard, and premium, where you can achieve speeds of up to 100 mm per hour. So can you see the GIF image here? Yeah. So
Yes.
this is how the technology works. Basically, Figure 4 is nothing but a DLP printing. So it uses a projector which projects light of UV spectrum magnified by the lens covering the entire XY area of 125 by 70. So the light passes through the film membrane of the resin tank, curing the resin, liquid resin in it. The resin is basically a photopolymer resin. And as the build platform moves up, it prints layer upon layer. So now the unique thing about this particular setup is that the film membrane of the resin tank is oxygen permeable. So it kind of forms a thin layer of oxygen window on top of the resin tank film. So when the resin is being cured, it won't stick to the film of the resin tank. Rather, it will stick to the build platform as the build platform keeps moving up. So there are no peeling forces acting on the part, you know. So the part won't stick to the film membrane, and so there are no peeling forces. So there is no pause in between where the part would peel off from the film membrane. So there is continuous elevation, and that's how Figure 4 is able to achieve ultra high speed printing. So like I mentioned earlier, Figure 4 is used for low volume production, fast prototyping in tens and hundreds of parts per month. I'll just play the video here. So you can save on time and cost of tooling. So the conventional mode of making prototypes would be to make tools, where you would inject plastics and get prototypes. So if you have to do multiple iterations, that would increase your per part cost. So by rather you can just 3D print your prototypes, do quick prototyping iterations, and save considerably on time and cost of tooling. So there's reduced per part cost, and also you can market your products faster. I'll just play a short video of another variant of Figure 4 standalone. This is not standalone, this is Figure 4 modular, which is not covered in the webinar. The only difference between the modular and standalone is that, this has a height of 346, standalone is 196. And also this has auto resin dispensing system. So I'll just play the video and I'll mention what I'm talking about. So the point being here, you can not only arrange the parts in XY area, but you can also stack the parts in Z direction, one above the other. So you can get increased throughput. Now you'll see here the print time is approximate around 4.5 to 5 hours, and you got 120 parts within that time. So imagine these number of parts, whether or not they're achievable by conventional tooling methods. And when we have to compare it with the room temperature vulcanization, silicone molding. So Figure 4 is quite affordable, reduced time to first part, and compared to 6 days with RTV casting, to only a matter of minutes with Figure 4 is achievable. And it's also accurate to 6 Sigma. Figure 4 delivers on accuracy and repeatability. So see, generally you can achieve up to plus or minus 100 microns for the first 25 mm of the dimension. But through our experience, we were able to achieve accuracies of up to 10 to 50 microns plus or minus. That's how accurate the figure 4 printing is. And you can see some figures here for a specific tough gray resin with the process capability index of to 2.46. A CPK of 2 equals 0.002 ppm out of spec. So that's how accurate and repeatable the figure 4 is. As I mentioned earlier, Figure 4 standalone comes with the proprietary software from 3D Systems, that is 3D Sprint, which is extremely user-friendly. It has an intuitive interface. So the file preparation for loading and printing is quite easy, even for someone who doesn't have any experience with CAD or any kind of software. They will learn this software within a couple of days to a week. So to get more hands-on experience on the software and the printer, you can enroll to IPMA's AIMTech's course, or you can even book a demo at SRT's Customer Innovation Center here at Marol, Andheri East. So you can get a complete know-how of the 3D printing process, the workflow, right from build preparation to printing and post-processing. And of course, it 3D Sprint eliminates the need for costly software seats. That's usually offered by third-party vendors. Now we'll jump on to the Figure 4 material portfolio. That is that kind of options that are available with Figure 4. So around 14 engineering materials are available with Figure 4. So we'll go through some of them, the major, which are majorly used in the market. So roughly they are categorized into prototyping, production, and application specific. So if you have to use tough ABS-like materials, like here, I want to stress on a point that these are not thermoplastics basically. So these are photopolymer thermosets, which simulate the properties of end-use thermoplastics like ABS or PP or PC. So if you have to have properties of ABS, which is your end-use material, you can use one of the tough ABS-like resins to build your prototypes, and then probably you can simulate the results with that of actual ABS, thermoplastic ABS. So they are broadly categorized into prototyping, production, and application-specific materials. So for general use, which are ideal for prototyping and modeling, we even have translucent and semi-transparent materials, which simulate the properties of acrylic, PMMA, or PC. There are also castable and sacrificial materials with which you can, cast metal parts. Tough ABS-like or durable PP-like materials which resist, breakage for assemblies. Even high-temp materials are available which can withstand temperatures over 300 degrees Celsius. Dental and medical materials are available. And of course, low shore, elastic, and silicone-like options with the rubber-like materials. Now, to start with, Figure 4 Pro Black 10, it's basically your go-to material for production of plastic parts. Go from CAD to manufacturing line in one day with toolless same-day production. It's a high precision resin producing parts with a smooth surface finish and exceptional sidewall quality. And it has excellent mechanical properties. So basically, this is the most versatile material that 3D Systems has come up with. So generally speaking, it simulates the properties of ABS PC blend, but where you would want to have ABS-like property, it works fine. Where you want to have PC-like properties, still it works fine. So this is the most versatile material that 3D Systems has come up with. Another material that is rigid white. So if you want to have same day production grade opaque white rigid plastic parts with biocompatibility, polished surface finish, and long-term mechanical properties stability, so this is your go-to material. So applications include, some electronic enclosures and small components, parts or devices, motor housings, and of course for snap fits. It's quite difficult to achieve snap fit parts with the thermoset resins, but we have been able to achieve with rigid white, rigid gray. This is one of the most unique materials of 3D systems, which is the high temp 300 amber. It's basically an ultra high temperature resistant with no secondary thermal post cure required. So it's used in applications which require high heat resistance. So it can withstand temperatures of over 300 degrees and having modulus of 4000 MPa. It is well suited for testing of high temperature components in application including HVAC, consumer appliances, motor enclosures, stators, molds. We have actually printed a mold insert with this material where we were able to inject around 100 PP parts. We just tried, we designed a closure, a cap, bottle cap, and we made a mold insert out of it, and then we tested it. So we were able to achieve around 100 samples. So depending on the design complexity, you can produce a small batch of parts ranging from 20, 50 to even over 100 parts. Of course, it won't work like a metal injection mold tool. However, you'll have to compensate for the high temperature and injection pressure. So it is always possible. So you can validate your designs, part design, you can validate your mold designs with this material. Figure 4 Med White 10. This one is a rigid white material for range of medical and industrial applications. So including where biocompatibility is needed. This is also sterilizable by autoclave and also where thermal resistance is required over 100 degrees. It delivers parts with excellent feature resolution and high definition. Another one in the same category is a rigid translucent material for a range of medical and industrial application. So, where it is translucent so that you can visualize the fluid flow. It also delivers parts with excellent feature resolution and high definition. Where you need high tear strength with long-term environmental stability, this is one of the unique materials, that is rubber black 10. It has high tear strength for hard rubber-like parts with slow rebound for touch applications like grips, handles, and bumpers, etc. Eggshell amber, it's a process optimized material for production of sacrificial tooling for casting silicone and other materials. So it is specifically engineered to withstand liquid silicone injection at high temperature and pressure. And it has intentional brittleness to shatter easily from silicone once the mold is filled and cooled. So its amber color allows for visualization of the injected silicone, and it also has high heat deflection temperature, so which are preferred properties for molds to be injectable. And there are these are from the tough ABS category. There is tough black 20. There's tough gray 10, tough gray 15. These are basically ABS like materials. The look and feel, they give the look and feel of injection molded ABS with long-term environmental stability. Now, every material of 3D systems has been tested for long-term environmental stability. So when these materials are used for indoor application, they will last for up to 5 to 8 years. If you have to use this for outdoor application, the life is up to one year to 1.5 years. So basically, since these are photopolymer resins, these are sensitive to direct UV exposure. So it's that their life would reduce if you are using it for outdoor application. PP-like material, which is the Flex Black 20, which gives high durability. Again, another one from the same category, which is Flex Black 10, high durability and flexibility. So I'll just run a video here so that you get to know what I'm talking about. So you see, there has been so much in terms of material development that earlier people would use resin-based 3D printing systems only for for the purpose of aesthetics, form, the looks. But they have 3D systems has come up with so many materials now, which you can actually use for testing functionality, not just form and fitment, but also functionality, which replicate the properties of end-use thermoplastics. Another material which is rubber-like, having shore hardness of 65A. So ideally, it's used for prototyping grommets, seals, hoses, sealings, keypads. Any kind of vibration dampening components. J-cast green for jewelry application for for optimized for investment casting of jewelry patterns. So to sum it up, basically these are the material options available with 3D systems, Figure 4 standalone. So there's there's a resin for almost every application there is, right? It covers the entire application range, and you have material options which match the properties of end-use thermoplastics. So be it form, fitment, or functionality, there's definitely a resin available which you can use. And we have all these resins in our Customer Innovation Center here in Marol, Andheri East. So in case if you want to book a demo, you can please feel free to contact us, and we can showcase our capability. Not just the Figure 4 standalone, we have different other technologies as well. So you can come here, have a look, and just experience yourself, right? So yeah, I'll hand over the next topic to my colleague Samir. He will cover the applications of Figure 4 standalone and also give some use cases examples. Right? To you, Samir.
Hello, good evening, everybody. My name is Samir Karandikar, and I will be your host for the second half of this presentation. So we will discuss about Figure 4 applications, and thanks to Mr. Pratik for giving us the brief on Figure 4, its technical specifications, and the different material capabilities that this printer possesses. So the background is that because Figure 4 is a versatile 3D printer, it has got about 20 plus materials that can be printed with this machine, and directly that affects the total number of applications that can be made possible or achieved by this printer. So we are going to display a few applications here, and then after that we will move on to the last topic of this webinar, which is the title itself, Figure 4, a bridge between industry and education. So that should hopefully give you an insight as to how education is sort of being reformed by using Figure 4 as the means of technology, and what is the current standard that industry expects out of a fresher engineer, and how APMA's AmTech program, who offers a course in Figure 4, helps you achieve that. Right. So as you can see in the image and in the material applications library discussed before, Figure 4 has got a wide variety of plastics, and you can see that they range in jewelry, dental, engineering, silicon molding, or rubber-based applications. So
Samir, sorry to interrupt,
yes,
but are you shifting the slides?
yes.
Because we are not able to see it, please. Can you just stop? Yeah, now it's better.
So are you able to see this slide?
Which
Figure
is
4.
this slide?
Yeah, it's application diversity actually.
Yeah, application diversity. Yes.
Yeah.
You full screen the slide?
Is it working?
Oh, not really.
Okay, just 1 second.
Yeah, sure.
Are you able to view it now?
Yes.
Right.
Okay.
So as I was saying, that Figure 4 has got a lot of application flexibility, and if you can see here that there are different types of products which are shown. So a few of them will show rubber, some engineering parts, something in jewelry, something in dental application, as well as something in silicon molding. So let's discuss what we can do. Applications over here is that the software 3D Sprint has a feature which lets you add texturing to your parts. So by adding a texture, it will basically replicate the end use quality of the material and also hide all the 3D printing lines that are maybe visible by some traditional technologies like FDM. So by using texturing tool, you can create injection molded quality parts, or parts which can definitely hide the fact that they are 3D printed. And it can also help you recreate your end use feel and form of the part that you are looking to achieve. And the next thing that you can do on most of these 3D printed plastics is dyeing or painting, or even electroplating those parts. So one case study here that you can see is these spectacles here that were printed. But if you observe the lens handle, and the portion is actually a lattice structure that is generated and only made possible to manufacture by 3D printing in one go. So these parts were printed and then basically painted. So this helps quite a bit because you get all of this factor just basically compressed in a matter of days rather than weeks, or maybe in some cases months, to get the end use prototyping part. So with these materials, it's very much possible to plate, coat them, or even color them, and considering them that they are your standard plastics. This is a case study where Figure 4's tough gray 15, tough gray 10, and elastic black 10 materials have been used together to create an electronic collector, and then highlighting and showcasing the fact that on one single machine, by using multiple different plastics, you can actually recreate something of a part that is shown on the right side. So the printing speed of all these parts is very high. It's about 50 per hour. So if you see or assume the height of this part to be somewhere around 50 so within an hour you can get all these three parts printed. And in fact, if you see the small chart that we've shown here at the bottom, then you see that the total build time that is required to make this entire assembly is somewhere around 3.5 hours to 4 hours. So in this case, you can literally get any of your ideas to design, and from design into production, and then actually make your design to manufacturing process pretty efficient. And because of Figure 4's capacity to just print using the same projector, you print using the same platform, there is no hassle of changing the material tray or doing some other things like changing the membrane. So all of this is pretty easy, a layman. So this is one case study of an automotive vent production. A lot of the top manufacturing automobiles in the world are basically using 3D printing now to recreate some of the internal plastic structures that they would want. So you can see here on the bottom that there is a AC vent, and they have actually used texturing to create the outside border, and then they have used the Problacton material to print the inner grills and use it as a snap fit assembly. So because of the layer thickness that can be achieved in Figure 4, which is anywhere between 10 to 100 microns, so it really creates beautiful looking parts, and the entire process of digital production is very convenient. So this is one case study in the automotive sector where such parts can be created. So this is a small pilot knob. Figure 4 has a material called the Tough Gray 15, which has got excellent accuracy, repeatability. So if you have small components and you want to have good dimensional form and fit, then you can use this you can use this material to create such parts. And again, the printing speed is also very high, about 62 per hour. So you can imagine that such small parts can be printed within 10 minutes. Here we can see that there were two materials in Figure 4 that are possible. So one is rubber 65A, which offers a durometer strength of 65, and another one is the eggshell molding. So with eggshell, you can inject silicon of any durometer. So in this case, these parts mold have been created with this eggshell molding, and then silicon has been injected to actually recreate different types of earbuds, so that you can really custom make such earbuds. A lot of us have problems because our earlobes and internal geometries are different, so a standard fit doesn't come for everybody. But because of 3D printing today, there are websites which allow you to literally custom fit such models by using a scanner, recreating your earlobe in CAD model, and then using that to create a 3D printed earbud shell, as you can see here. So the build time is pretty fast. It's just 12 minutes. And a demand for this has really been on the rise, since a lot of infections for the ear are now being reported, because a lot of us have got this habit of listening to music while traveling. So this is a very strong case study, and those who are interested should surely look into it. So this is again just one of another electronic slider case applications, just to show how electronic components in terms of its sliding and friction can be made possible for testing and finishing. So figure 4 also has rubber-like prototypes. So we have two materials, which is rubber black 10 and rubber 65. So rubber 65 is 65A and rubber 10 is 97A. So depending on the parts application, you can create such small parts very quickly on the figure 4, and they provide excellent mechanical properties. And all of these parts are very, very much production quality. Jewelry is also possible using figure 4. You have a specific material which has got a very good burnout ash content ratio. So you can really create precise geometries on figure 4 and then print them in these jewelry casting materials, and then use investment casting to literally put in any material, any metal that you would want. So if you look at the details of this part, then you can see how closely the virgin features are maintained. So figure 4 in jewelry is also pretty much an established version now. So like I said, figure 4 also offers materials which are approved by FDA in one of their classes 1 and 2. So obviously these are biocompatible, but they aren't bioimplantable. There is a difference. Med-Am 10, you can get two different types of materials. One which is translucent, so you can observe the fluid flow which is there inside the body of the part, and one which is Med-White 10, which offers much more thermal stability and can be used for medical equipments. They have got a pretty big heat distortion temperature, so you can be assured that they are autoclavable and also sterilized. So another example of ear lobes, you can see here earbuds that have been custom printed using the Tough Grey 15 material. So just to show how parts are printed in batches and in pairs, and such parts can be really printed very fast in about 30-40 minutes. So one more application that we have here is the dog leg prosthetic application. So unfortunately, you see animals sometimes with no legs or maybe a missing arm, and in this case, prosthetics or robotic limbs is now on the rise. So in such research facilities and design studios, 3D printing is a must-have option because it allows you to print parts with a lot of different mechanical properties. So you can create really strong and stiff structures and then assemble it. So with figure 4's size, creating something for dogs or let's say animals of that size is a pretty big deal because the build volume allows you to do so. So this one application is in aerospace, and it's again printed in the Tough Grey 15 material. So you can see the challenge here was to deliver production level materials and something that has a fast turnaround. So these parts can be printed in the figure 4 really very fast, and the aerospace industry found an application to justify printing their parts on the figure 4 machine. And finally, we come to some eggshell molding applications. So eggshell molding is one material which allows you to 3D print the mold. So you can really take your mold designing capacities to its maximum. And then in that case, you can use any kind of silicone that is commercially available, and then use hand injection to basically inject it and then print whatever material properties you want using the eggshell molding. So this is one application that has really changed the industry in terms of 3D printing and production, because earlier creating a mold used to take a lot of time, it was expensive, and some parts which cannot be traditionally produced and can be produced with 3D printing sometimes hit the roadblock because they don't have the specific required grade of rubber. But with the actual molding application, you can have any durometer grade silicon and then do the process that we spoke in order to get the parts of your choice. So the final one that we have got here is again a comparison between DLP technology, so a part that's printed on figure 4 versus something that's printed in FDM. So FDM inherently has the property of showing its layer lines, because the resolution on an FDM printer typically starts at 100 microns and goes above up to an mm. But with the DLP projection printers, you have high resolution in the z-axis, which is somewhere around 10 microns in case of figure 4, and it can go up to 100 microns. So the applications are justified, the materials and part properties are justified, and we have to find an application where this printer can be put to use, because in most of the plastic industry, 3D systems figure 4 has found its way. So that will be all from my side for this figure 4's introduction. But I would like to show you now how APMA's MTech 3D Systems figure 4 course can basically bridge the gap between, let's say, education and industry. So what I mean by that is uh, so there has to be some starting for point for, let's say, a professional who is looking to use 3D printing in his setup, or let's say a student who wants to make a career in 3D printing. So 3D Systems has designed their own course on this 3D Systems figure 4 machine, and they have selected figure 4 because it is a very good starting point for young professionals who are looking to make the switch to 3D printing, whether it's on the education side or it's on the industry side. It's a very easy machine to use. The whole objective of using Industry 4.0 system is to make sure that human labor is minimal. For the past 6 years, this figure 4 machine has been running excellently. There are more than 200 installations in India. Tata ITIs are using it at full force. And trust me, the reports and the feedbacks are extremely positive. Never has been there a case where this machine has actually failed in terms of mechanical failure or hardware failure or any such thing. So has a 3D printer, and because 3D Systems is the company that has patented 3D printing way back in 1984, so it makes sense for somebody to get trained on a program which is curated by them. So this is the syllabus that I wanted to show you. This comes right from 3D Systems Academy. So MTech has partnered with 3D Systems to collectively teach this course in India. There is nobody else who is doing this thing. So the course or the objective of this course is basically to develop the skills and knowledge to, at the very least, become a very good 3D printing technician. So you can see here that the typical role of a 3D printing technician is this one. So you can select the printer or the CAD file, you import the CAD file. If there are any changes to be made to the CAD file, like in terms of design or repair, then the technician does that on the software. Then once the part is prepared properly, then it is sent to the printer. In between, you can either support it, or if it is self support, then simply put it to print. And once the part is printed, then you can use post processing like sanding, painting, electroplating, etc. And then finally use key quality control and ship it to the customer. So uh, all of this is taught in that program, right on the 3D Systems course on figure 4. And each of these steps will be taught according to the industry standards. So this is what you will be learning once you enroll in this course. So you get to get hands-on with 3D Systems Print software, and with that software you will get an insight into how the world of 3D printing works. And it's a very much industry leading software. There is no other software that comes with even close to this. So it's a very good starting point, to reiterate once again. So what is the audience, target audience for this program? So from our perspective, and having data analysis from students who have completed it, age is not a limit or restriction. Just somebody who understands English can participate in this program. It's as simple as that. And maybe some basic mechanical engineering knowledge is required. But again, that will be refreshed, revised, or even taught afresh in this program. And all of this content is there in the let's say learner's workbook. So you can very well be assured that if you want to study at your own pace, you can study at your own pace. So this is just the course schedule. There are about 19 topics, and the official time to finish this is about 70 hours. But we have seen students complete this within a week because of time constraints. They would put in more hours, like maybe around 4 hours a day, and accelerate the learning process. So that is also fine. AMTech is flexible with that, and you can always collaborate with them and make it workable. And finally, upon completion of this course, you do receive a certificate which is directly coming from 3D Systems. So that's a very good, like a standout ribbon on your resume. So you never know, such things do or might come to help in the future. And for young professionals, it's a very good starting point once again. So that's all that I have to share with all of you today. All of these documents that we are showing will be given to you after the presentation by Nikita. So we are now open for questions, and if anybody has anything to say, kindly proceed.
Okay, some people are writing in chat box, so I have answered most of them. But if there is any technical questions, our speakers are ready to answer you. So y'all can just drop down your questions in the chat box.
If anybody is shy to ask questions, you can just type them in the chat box.
Last 5 minutes are remaining.
Nikita, I would like to ask a question.
Yes, sir, please.
So, Samirji or Pratikji, whosoever maybe can answer, anybody can answer. Now, I think in the there may be some users, there may be some out of in participants, there may be some students as well. Now, when you say that these products or the 3D printed articles are affordable, now there may be some users or end users or some injection molders in the participants. So, can you please guide me that what do you mean by affordable? If you, at all you have some cost comparison of 3D printed product vis-a-vis injection molded product, then it can give us a better picture.
Hello. Yes, sir. So basically, by affordability, we mean no. See, here we have given a comparison between conventional method of manufacturing plastic parts. I'm not comparing the end-use production. I'm not comparing the mass production. We're talking about the prototyping stage, where conventionally people would go for making molds just for prototypes, and that would increase the lead time. The mold making it takes weeks, and even it's a costly process. Making a mold would one has to invest in lakhs. So that whole process is kind of eliminated, where you can have prototype parts made in minutes or even within a day. So that whole process of making a mold is eliminated. So that's how we say that it is an affordable solution for your prototyping application.
Okay.
So this is not a
not
comparison
production.
between making 3D printed parts for end use application. Now, if I have to just for an example, if I have to make a water bottle cap, of course it is going to be injection molded for mass production. So there's no comparison with 3D printing. 3D printing is of course going to be costlier and time consuming. But with injection molding, you can get these bottle caps made in few seconds. You can produce lakhs and lakhs of parts. What I'm talking about here is the prototyping application, where you can produce prototypes within minutes, within days, compared to what you can achieve with conventional tooling.
Okay. So conventional things of fabricating the prototype article is done fast over here, right?
Yeah.
Okay.
So
Fine. Thank you.
just to add on that point, during new product development stage, where you have to iterate your designs, you go through a number of iterations. You design and then you make a prototype. Now, if I have to go for conventional method of tooling, your prototyping process is going to be very costly. So
True.
the number of iterations can be made quicker without any investment in tooling.
Okay. Okay. Thank you.
I have one question. Pratik,
Yes, sir.
you're talking about eggshell molding. Are there
Right.
any case studies in India, or have you done anything on this?
Not yet, but we have had queries, and we printed some benchmarks, and that's it. I mean, yeah, we may have some case studies outside India, but as of now, nothing. There's no use case in India yet.
Okay.
I mean,
So if
no.
you come across anything, you can definitely share with AIMTech so that we can
Yeah,
take
sure,
it
sure.
further.
We have actually printed some parts in eggshell molding.
Okay.
Yeah, we even tried injecting the silicone, and we were able to get the induced part. But as of today, nobody has purchased the printer for this particular application.
So you have this resin with you, right?
Yeah, we do.
Okay, so we can conduct some trials if required.
Yes, definitely.
Okay, thank you.
One question in the chat box is pending. This 3D printer showed you are feasible for biopolymer. Who will take this, Pratik or Samir?
I will repeat the question.
Yeah.
So,
With
Mr.
polymer, is it, do you mean bioimplantable or it's derived from natural sources? So I can answer both questions. It's just that for not for 3D systems figure 4, these are all synthetically made materials and resins, basically derivatives from petroleum. The thing with biopolymers in terms of sustainability and nature is that for the fuse deposition modeling process, or FDM, in that you have a polylactic acid, which is derived from let's say biopolymers. So that is one thing, and the second one is that for bioimplantability there is no material, at least on the resin side, that can be done. However, there are thermoplastics like PEEK and Ultem, which are FDA approved class 3 implantable. But from what we have heard and from our experiences, they still cause an issue after a few years. So the best thing is to go with ceramics, because ceramics then eventually fuses with the bone, which again we have a solution for in 3D printing, or you go for implantable titanium. So I hope that is what you were looking for with the question.
Okay, are there any other questions? You can just drop it into the chat box. I will share the details with the concerned persons who have asked me certain questions. So I will mail you all the details regarding our course, and also share the PDF that Mr. Samir have shared with us today. So if there are any questions, we can move forward. If there are no questions, so we have already exceeded our time. So are there any questions? You can just drop it into the chat box, please.
So there was one question that I think might be applicable to everybody. So somebody has asked that after completing this 3D systems offered program, what are the chances of getting a placement? So as far as I am aware, AMTech does have the AMTech does have the capacity and a dedicated person for placement assistance, which is not offered officially by 3D Systems but by AM Tech, and it's a perk, I believe, because they are the largest consortium of plastic players in India. So as far as I know, they do help for placements, and especially with 3D printing. Also, there is one more thing. For those people who take up this course, they have an opportunity to intern with our company. So after, let's say, completion of this program, you wish to work with us, then obviously we can go through a formal process with the interviews and everything, and then take you on board for a couple of months. And if the performance is well, combined with a lot of other experiences, if applicable, then it can convert into a full-time opportunity. So one more question. This program unfortunately can't be done in its full capacity if it is done online only. It is requested that the person comes to the center here in Mumbai to do it, because if you have to receive the certificate from 3D Systems, then they expect you to do a couple of exercises which involve like printing the part and getting accurate results. So that can be done. However, if you wish to just learn the theory part online and then maybe later on give the exercises and exams at a later stage, again, it can be workable with AMTech. And yes, there is a cost for this program. Yeah, but it is very feasible, I believe. And it's in fact, according to our survey, it is better than what most of the IITs offer on NPTEL. So I think we can wrap it up, Nikita, because there are
Yes,
no
I
more.
have already shared my email ID in the chat box. If there are any other questions, we can help you find the answers. Our speakers are always there to guide you all. So I think that's about it for today. We will keep posting you with our latest webinars and courses. So please stay tuned with ICMA's MTech, and also to visit our website to understand our latest courses coming up and helping plastic industry to give skilled labors. So that's about it from me. Thank you so much for joining, everyone. So, thank you.